What we're going to do today is we're going to go over the reactions and equations quiz, questions 1 through 26. Number 1, which observation does not indicate that a chemical reaction has occurred? Keyword here being not. Okay. Formation of a precipitate, that would be an indicator of a chemical reaction. In the equation, you would see parentheses S written after the product as a solid would be formed. Production of gas, that is not correct. You would see parentheses G written after that product. Evolution of heat and light, that is not accurate. This would be an indicator that a combustion reaction is occurring. Eliminating all other possibilities, D has to be the answer. Change in total mass of substances, that is not an indicator that a chemical reaction has occurred. The total mass of your substances will remain the same. Reactants will equal products because of the law of conservation of mass. Moving on. Number 2. When the solid produced by a chemical reaction separates from the solution, that is going to be called your precipitate. What's the small whole number that appears in front of a formula in a chemical equation? A subscript? No. A subscript is written here. The 2 is a subscript for water, H2O. Superscript? No. Example, sulfate, SO4, with a -2 charge. This superscript, -2, indicates the charge of your sulfate. The 4 would be a subscript telling you that there's 4 oxygens in this case. Ratio? No. Coefficient? Yes, that is the coefficient is the small whole number that appears in front of the formula in your equation. The set of coefficients in your reaction will provide you with the mole ratio, so that is derived from the coefficients. Number 4, according to the law of conservation of mass, the total mass of the reacting substance is always more than the total mass? No. Always less? No. Sometimes more, sometimes less? No. Always equal to the total mass of the products. All right, law of conservation of mass. Mass cannot be created, mass cannot be destroyed. In the word equation, sodium oxide plus water yields sodium hydroxide. The formula for sodium hydroxide is represented by. Make sure you pay attention to what the question is asking for. In this case, sodium hydroxide. Sodium is Na. It has an oxidation state, a charge of +1. Hydroxide, polyatomic ion, OH-. When we are given the cation, sodium, and the anion, hydroxide, we want to write its complete formula. All you have to do is take that charge, that oxidation state, and drop it down. There'd be imaginary ones there. You don't have to write the ones as subscripts in the chemical formula. That's why it's just NaOH, no subscripts involved. Now be wary for the final exam. It's easy to change things up. Instead of asking for sodium hydroxide in this case, I could ask for sodium oxide, in which case you have a new response as a correct answer. Looking at sodium oxide, sodium again, Na with a positive charge. Oxide is O with a -2 charge. That's because it's in group 6A, 2 away from being a 2 away from being a noble gas. Gains 2 electrons, giving it that -2 charge. We can crisscross the charges likewise, bringing them down to identify the subscripts. Subscript of 2 for sodium, a subscript of 1 for oxygen, leaving us with appropriate answer of D. All right. Recall that was because we're looking at sodium oxide instead of sodium hydroxide. Another way of determining the subscripts can also be found using least common multiples, LCM, least common multiples. A least common multiple of 1 and 2 is 2. 1 times 2 is 2. 2 times 1 is 2. Moving on from number 5, in an equation, the symbol for a substance in water solution is followed by, that would indicate liquid, that would indicate gas, this would be aqueous, dissolved in water, and that would be solid. A chemical formula written over the arrow in a chemical equation signifies not a byproduct, not the formation of gas. That would be parentheses G after the chemical formula. A catalyst for the reaction, that is correct. An impurity, that's just bogus. When the equation Fe3O4 plus Al yields Al2O3 plus Fe is correctly balanced, what is the coefficient of Fe? For this, we're going to have to balance the entire formula. Let's do it step by step. Good, look at iron. Usually I want to look at the first element first and go from there. But in this case, iron is very easy to balance if we look at it first. It'd be 3 irons, you just put a coefficient of 3 out front of this iron. However, you can see, or hopefully you can see, that oxygens are going to be your hang up. You have 4 oxygens as a reactant, 3 oxygens as a product. The least common multiple between 4 and 3 is 12, where 3 times 4 is 12, and 4 times 3 is 12. All right, we're taking these two guys, multiplying them together to get 12. We're taking these two guys, multiplying them together to get 12. That's how we balance our oxygens. In balancing the oxygens with the coefficient of 3, now look at irons. 3 times 3 is 9, so we need to put a coefficient of 9 out front on this side. And if I look at my aluminums, 4 times 2 is 8, so I'll need an 8 for my coefficient there. The coefficients in order should be 3, 8, 4, 9. So iron would be D, 9. Which coefficient correctly balanced the formula equation? Here, to balance this guy, just start at the beginning. Notice we have 1 nitrogen there and another here, so that's 2 nitrogens and 2 nitrogens. Nitrogens are balanced. 4 hydrogens versus 2 hydrogens. Well, if I put a coefficient of 2 in front of my water molecule, I have 2 times 2 is 4, balancing with my 4. 2 oxygens, 2 times 1 is 2, 2 oxygens. Coefficients in order, 1, 1, 2. The equation AX yields A plus X is a general form for A, not a synthesis. Synthesis, you will have 2 things turning to 1, synthesizing together. Decomposition reaction, indeed. Okay, 1 compound is break down into 2 or more simpler substances. Combustion reaction, no. Combustion reaction has a general form of CXHY plus O2 yields CO2 and water. And your signal displacement should have a general form of AX plus B yielding BX plus A. All right, you'll have 1 compound plus a single element yielding a new compound and that displaced element. All right, next we're going to take a look at number 11. The equation A plus X yields AX is a general equation for our synthesis reaction. Okay, we have 2 separate things combining to form 1 complex thing. It's not a combustion reaction. You'd be looking at O2 as a reactant and CO2 as a product. Ionic reaction, that's bogus. Double displacement, incorrect. You have 2 compounds, AX plus BY, that will form two new compounds, bx plus ay. What kind of reaction does a single compound produce two or more simpler substances? That is our decomposition reaction. Synthesis just given, single displacement given with question number 10. Ionic reaction, again, just bogus. The equation a plus bx yields ax plus b. That is our example of a single displacement reaction. Okay. The reaction represented by our equation, this single element plus another single element yielding a more complex species, you are looking at our synthesis reaction. Right? A plus x yields ax. It's an example of a synthesis reaction. The reaction presented by the equation PbNO3 taken twice plus Ki yields PbI2 plus KNO3. We got two compounds forming two new compounds. This guy is just like that. Okay, so this would be a double displacement reaction. Reaction represented by KClO3 yielding KCl plus O2. This, you have a single complex substance breaking down into one, two, or more simpler substances. We have a decomposition reaction in this instance. Number 17, reaction represented by chlorine, plus potassium bromide yielding potassium chloride, and bromine is an example of one thing, chlorine will be kicking out bromine, okay, displacing bromine. Bromine is now all by itself as a product. This is a single displacement reaction. Next up, number 18, the decomposition of a substance by an electric current is called electrolysis. All right, that would be shown as a symbol over the yield, or as electricity over the yield symbol. You can see that electrolysis of water, H2O, decomposes in the presence of electricity. Okay, I'll just abbreviate it to form hydrogen gas and oxygen gas. Somebody did that for their gas production in the gas production laboratory. Moving on to question number 19. Some acids, such as carbonic acid, decompose into nonmetal oxides and water. Carbonic acid, what we're looking at is H2CO3. Oops. H2CO3 will decompose into CO2 and water. CO2, this is your nonmetal oxide. All right, that's your nonmetal oxide. In a double displacement reaction, hydrogen chloride and sodium hydroxide react to produce sodium chloride. Another product is, in this case, it's going to be water. This is an acid-base reaction, actually. Hydrogen chloride is HCl, and sodium hydroxide, this is your base, NaOH. What'll happen? HCl plus sodium hydroxide will form your NaCl and your water. All right, what happens? Hydrogen will displace sodium, and vice versa, sodium shall displace hydrogen. Double displacement reaction. End up with sodium chloride and HHO, or H2O. What's the balanced equation when aluminum reacts with copper 2 sulfate? All right, So we got aluminum. It shall react with copper 2 sulfate. Copper 2, that is +2. And sulfate is SO4 -2. That is the sulfate ion. We'll need one of each of those. Okay, so the actual formula, all we need is no subscripts. We don't need to worry about the charges. We don't need to worry about the oxidation states in writing the formulas. This is going to form aluminum sulfate, Al SO4, and copper. Now, what are the subscripts for aluminum and the sulfate in this case? Aluminum forms a +3 charge. Sulfate again is -2. If you recall, we could use the least common multiple method, LCM. The least common multiple between 3 and 2 is 6. So our subscript for aluminum needs to be 2, because 2 times 3 is 6. Our subscript for sulfate should be 3, because 3 times 2 is 6. You got a -6 and a +6, cancel out, net charge being 0. And get rid of my oxidation states. Those are not necessary in writing the formulas. Last bit is we have to balance this guy. To balance this guy, let's look at it. 1 aluminum, 2 aluminums. Let's throw my coefficient of 2 out front. 1 copper, 1 copper, 1 sulfate, 3 sulfates, 3 sulfates, 3 sulfates, 3 coppers, 3 coppers, and we're balanced. So what we're looking at, option B. Last few questions here. Number 22. What can be predicted by using an activity series? What you can predict is whether a certain chemical reaction will occur or not. It will be A. Predict what happens when calcium metal is added to a solution of magnesium chloride. In this question, what you'll need to do, you'll need to pay attention to calcium, and you'll also need to pay attention to magnesium. These guys are both the metals. Look at them up on your activity series. If calcium is higher than magnesium, then the reaction will occur, and calcium will displace magnesium. Since calcium is in fact higher than magnesium on the activity series, the reaction does occur, and calcium chloride is formed. Predict what happens when zinc is added to cold water. This is a simple read question. Look on the activity series, you'll see zinc, and zinc will react with steam, but it will not react with cold water. Right? No reaction will occur here. Predict what happens when nickel is added to a solution of potassium chloride. Look again on the activity series. Does nickel rank higher than potassium? These are your metals. All right, nickel is a metal, potassium is a metal. So the displacement that could occur would be nickel displacing potassium. However, potassium is more active than nickel, so no reaction occurs. Number 26, which reaction does not occur? What we're going to do is we're going to pay attention to either the metal or the non-metal. One of them is going to get replaced. All of these are single displacement reactions. Compound, single element, compound, single element, compound, compound, single element. The sodium in this case, for example, versus the zinc, these are both the metals. Will let the reaction happen or not? Look for sodium on the activity series. Sodium is more active. So it will displace zinc. It's going to kick zinc out and will form sodium fluoride and zinc precipitate. Here, we got iron trying to displace copper. Is iron higher on the activity series than copper? It is. So this will displace the copper. The copper will leave. We'll have iron 2 chloride and copper precipitate. Next question, HCl plus magnesium. Is magnesium higher than the metal? Is it higher than hydrogen? It is. So that reaction occurs. We end up with magnesium chloride and hydrogen gas forming. Here, we're looking at is fluorine higher on the activity series than chlorine? Or is chlorine higher than fluorine? When you compare those two, fluorine is higher than chlorine. So no reaction will occur. The answer, which reaction does not occur, is A in this case.